and this is your sync function, 2w t minus n. So this formula is your reconstruction formula. So if you see carefully this formula, so this is the sampled version. Actually, if you see carefully, it's a multiplication of the sample and the sync function. So what is the meaning of this? So this sample signal is giving the amplitude of the sync function. Okay, so amplitude of sync function is different for different sample signal. So finally, when you have at the output side, you have the summation of. So this figure actually I will show you that figure because where is it? Yeah. So this is the main figure. If you see, if you see carefully, this is your low pass filter here, and this is the transfer function. So all of you know, all of you read in the signal system, the transfer function is nothing but it is the response ratio of the response and the excitation. So whatever the response you have and the excitation. So if you see, this is the transfer function of the low pass filter. So the bandwidth is simply this is. We just take the half portion. So this is the image. So this is your bandwidth. We say this is W. Here it is defined B, but it is, you can define B or it's W or it's FM, the highest frequency of the message signal. So if you take the Fourier transform, the Fourier inverse of this, the Fourier inverse Fourier transform, inverse Fourier transform any rectangular function. So the inverse Fourier transform of any rectangular function, so you have a sync function. So this is your sync function. Okay, so here it again it's W, it's not B. So this is your W. So what will you obtain? So as your the constructed signal is empty, is that it's n equal minus infinite to infinite m n by 2w and the multiplication of sync, and this is 2w t minus n. So if you see, it's a summation, and the summation is starting from minus infinite to the infinite. So if you this is showing the sample. These are the samples. Okay. So each sample is the ideal form of this rectangle pulse. So if you make the bandwidth of this rectangle function is 0, so that becomes your impulse here. So if you see, so that will give you the sync function. So this is one impulse and this is the sync function of this. This is another impulse, the sync function of this. This is another. So this, if you add this and if you take these points, so that will give you the original signal. Okay, so this is the way, by using the low pass filter we can reconstruct the message signal, original signal, because this is used at the receiver side. So all of you know, when the signal comes at the receiver, you need to recover the original signal. Without original signal, it is very difficult to say what we have sent at the transmitter. So that is why we need the original signal. Okay, so this is the simply the revision. If anybody any doubt, any query, please ask.
सर ये सी डायग्राम जो सैंपल सिग्नल आया है एमटी इस समेशन का फुल इनवर्स ट्रांसफॉर्म है ना?
हाँ 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 हाँ.
ठीक.
So actually you this is the systematic. I just uploaded all the notes, if you remember. So you just go through my notes, and the whole process is shown. I just saw that again. This is your lecture 2. Yeah. So you can see. So we start empty signal. So this is your message signal. Okay. So we start from here, and if you take the Fourier transform of this message signal, so this is your band limited signal. Sometimes we say it's a band limited because the maximum frequency, because this is single signal, and single signal has some frequency. A frequency is FM. So we say this is your bandwidth, half bandwidth. So this is like a low pass filter. Okay. So, and if you do the sampling, and after sampling you have the sample version of the signal like this. Okay. So all these. Okay. So again the same thing here, empty. The pulse train, you have sample version signal here, and then reconstruction filter to get the empty. So this is the block diagram, how you can recover the signal when you have the low pass filter. Okay. So this is nothing but this is your sample signal. ये आपने पहले, you already done this when we are doing the sampling. Okay, so simply multiplication of two signals, the message signal and this. So here we did this, the multiplication of the message signal and the impulse train. That will give you. Then we use two methods. One is by taking the Fourier transform of the message signal and the impulse, and then the product. So that will give you the convolution. The product of or multiplication of two Fourier transform signal will give you the convolution. So with the help of convolution, we generate one formula. So this is C. MF is the Fourier transform of message signal. Okay. So MF is the Fourier transform of message signal, and SF is the Fourier transform of the impulse function. So if you take the convolution of both, that will also give the samples version of the signal. So now the samples version of the signal is in terms of the frequency. Okay. And if you see here in this equation, this is also in terms of the sample, but here the sampling period is TS. Okay. And now if you see using that equation, so Fourier transform of impulse function is nothing but its exponential function. You can write this, and if you substitute this, so this becomes equation this. Okay. This is discrete Fourier transform. You already did in your signal system. Okay. Now using the sampling theorem, if you remember, or using this low pass filter criteria, so this MF is only available for frequency greater than this W. After this W, this becomes 0. So we use this concept here because we are using low pass filter. So what the low pass filter is doing, other frequency component, the high frequency component, it will suppress that all simply. Okay. So see, so if you expand that equation, the earlier equation, the equation number 2, which we seen earlier. So this is your first term. This is n equal to 0, and this is the high frequency component. So using the filter, we just suppress this term. So after suppressing this, you will have this. So now if you see, this is your impulse function, or this is sample function, sample signal, and this is the product of frequency component and the message signal in Fourier transform. So if you take the Fourier transform of this, that will give you the message signal. So we use this, and if you just do the change this position, mf is equal to 1 by s ms, and this is mf, and if you substitute the value of this, so that will give you this. So it's a very simple formula. So this is the reconstruction. This is, now you see, this is in terms of frequency, but ultimately at the output you need the signal in terms of time domain. So for that we take the inverse Fourier transform of this equation, and if you take the inverse Fourier transform of this equation, that will give you this equation, and this equation, if you solve this exponential function, this will give you the sinc function. So we just replace this integral with the sinc function, and the sinc function is simply this sinc 2 wt minus f. So this is the final expression of the, so from this you can see the sinc has different amplitude for different pulse. So if you take the summation, that will generate the original signal. So this is about the how we can reconstruct the signal when you have the low pass filter. Okay, if anybody any doubt, any query, please ask, because the next topic is slightly more difficult compared to this, and we will see how we can reconstruct the signal, message signal, when we have the band pass filter. Anyone please? Sai, Sudhir, धीरेन्द्र, राजीव, फिर आगे हाँ बच्चे ये रिपीट कर लेना, ये मैंने नोट्स डाला हुआ, अगर कहीं पे क्वेरी है तो प्लीज पूछ लेना, बिकॉज इफ
सर।
हाँ प्रेमलता पूछो।
हेलो सर।
हाँ हाँ पूछो प्रेमलता।
सर यन क्या है?
आवाज कम आ रही है प्रेमलता।
सर यन
है प्रेमलता, आवाज कम आ रही है, योर वॉइस।
सर व्हाट इज यन?
सॉरी, एनीबडी कोई बताएगा क्या पूछा प्रेमलता ने?
सर नेटवर्क
तक्स क्या आप सुन पा रहे हैं? कोई एनीबडी प्लीज हेल्प मी। ईशान
सर नहीं, आई कांट अंडरस्टैंड।
प्रेमलता कुछ बोल। हाँ, आई एम स्टिल नॉट अंडरस्टैंड। बादल
नहीं सर, नहीं समझ में आ रहा सर, उनको बोलो कि वो चैट बॉक्स में लिख दे।
हाँ, प्रेमलता चैट बॉक्स में लिखो। ओके, यहाँ तक किसी को कोई दिक्कत है, कोई क्वेश्चन है तो पूछ लीजिए प्लीज। नाउ आई विल गो अनदर इम्पोर्टेंट टॉपिक। Okay, so I hope nobody have any query, any doubt. So another interesting topic is the reconstruction of original signal when you have the band pass signal or band pass filter. Okay, so again I will take the help of this board. Okay, so this topic is, it's a very interesting topic and will be useful when you discuss the pulse amplitude modulation and pulse population. So this is your sampling. One second. This topic is so this is the topic. So remember, so when you do sampling or you do the conversion from analog to digital, so you will see you have two kind of signals. Either it's a low pass signal or it's a it's a band pass signal. So if you see, so first of all of you understand what is band pass signal. And remember, in case of band pass signal, you have fixed band of frequency, or in fact sometimes we say it's a narrow band of frequency. Now first we will see the comparison between band pass and low pass signal, then we will start our discussion. So if you plot, see, so this is GF, or if we take this is you can say this is your GT. Okay, this is message signal. Okay, so when you see that this is GT, and when you have the low pass signal and you take the Fourier transform of this signal, so that will give you FM minus FM 0 here at this point, because this point will measure at the 0 frequency, so that will give you 0 amplitude G0. So this is the spectrum when you see, or this is low pass spectrum. Or you can set a transfer function of low pass filter. Okay, so up to here, so we already discussed how we can reconstruct the message signal when you have the low pass. Okay, now we will see what will we do when we have band pass signal. So in band pass signal, the spectrum or the transfer function is this. This is your 0 frequency, and this is some way its carrier frequency here, and this is minus FC here. And these two you can define, this is FC plus FM, or this is your FC minus FM. Okay, and sometimes, as I already mentioned, sometimes we say this is W and this is also W. So if you find this bandwidth, so this is your bandwidth. So bandwidth is your twice of Fm, or we say it's a twice of W. Similar, if you see here, this point is your minus Fc minus Fm, and this is minus Fc plus Fm. Okay, so see, this is the spectrum difference between the low pass signal and the band pass signal. यहाँ तक किसी को कोई क्वेश्चन एंड और कोई डाउट तो प्लीज आस्क, फिर मैं आगे मूव करता हूँ. ईशान,
Yes, sir.
any doubts up to here? So this is simply the difference between
No.
the low pass spectrum and the band pass spectrum. Anybody? Maharishi? Maharishi, are you here?
Yes, sir. I'm here, sir.
Okay. Manali?
Yes, sir.
Do you understand?
Sir. Yes, sir.
Okay, so this is the spectrum of the low pass filter, and this is the spectrum of the band pass filter. So what is your anybody help me? Can you help Isan or Anmol Sina? Can you help me? So what difference you are looking here, observing here between the low pass and the band pass? Anybody? Anmol Sina?
Yes, sir.
Can you tell me the difference between low pass and band pass here? So simply again I am just drawing the response. Okay, so this is the transfer function, or we say this is HF, not the spectrum. This is the transfer function of the LPF. Okay, and for this transfer function what will we use? So this is your bandwidth. We say this is Fm, or sometime it is your W. Okay, so this point is your Fm or W. So some books use Fm, some books use W. So both are the same, so don't confuse. So if you see in case of low pass filter, so this is the response. All of you familiar with the low pass response. The low pass response is this. So this is the low pass response. Low pass filter. While in case of band pass, what response do you have? So the response of the band pass is this. So this is your, if you see, this is matching with this. So this is low pass response of this side, the positive side. And if you see, the frequency is decreasing, the negative side. So this is low pass filter in this side. So what will be the observation? Anybody? So
Can you repeat that once? What was the question?
okay. I'm repeating some. So I'm just drawing again.
No, just the question I heard. And
Yeah.
I think the question.
Okay. The question is, what is the difference between low pass and the band pass here? Now you understand. See, this is low pass. This is band pass. Okay. So if
Sir,
you see,
LPF response is one-sided, BPF is double-sided.
yeah, okay. But what in real sense, double side, it's here. If you see, it's a mirror image. But in real sense, the band pass response is this. So if you see, so this is your ZF, and here we say this is ZF upon under root 2, and that will give you some point here. So this is your F1 and this is your F2, and the bandwidth is F2 minus F1. Yeah, exactly. If you see here, the difference between two, it's like a mirror image of one side response to the other side. So here it's negative Fc here is positive FC. Okay, but in real sense, if you have the band pass response, so that is slightly shifted either the negative side or your positive side. It's not at the origin, remember. So in case of BPF, band pass filter, the response is not at the origin, but it's slightly away from the origin, so not here. If you see it at origin, so that is the ideal transfer function of low pass filter. So in low pass filter, we imagine whatever the response is this side, the same response is repeating this side. So it has two cutoff frequencies. In fact, one cutoff frequency here is positive FM, here is negative FM. But that transfer function will work in both sides. But in case of band pass filter, if you see it at origin, so it is not a band pass filter. So it is like a low pass filter, and the response in both sides. The band pass filter is this, which is away from the origin or away this side, like this. So this is your band pass filter. And if you see at the center, we say this is center frequency FC. So now see, it's very interesting. It's a summation of two LP. This is LPF1, this is LPF2. So here this is one LPF, this is LPF2, here it is LPF1. So if you understand this figure, so you will understand the reconstruction of the band pass filter, in fact sampling of the band pass filter. So what we do here, we say the band pass filter is nothing but it is a summation of two low pass filter. Okay, or we say sum of two LPF. Okay, so now how we differentiate this? So for the difference purpose, the two response. So we say the BPF it's a summation of two low pass filter, and in fact two low pass filter response. So we say here one low pass filter is in phase and another low pass filter is quadrature phase. Okay, now tell me if anybody has question, query, कुछ भी हो जो भी पूछ सकते हैं प्लीज, क्योंकि यहाँ से फिर आपका स्टोरी थोड़ा डिफिकल्ट स्टार्ट हो जाएगा. मुझे नाम लेके पूछना पड़ेगा, ऐसे यहाँ जाना पड़ेगा.
सर
बादल पूछो.
तो सर इसमें क्वाड्रेचर वाला और वो LPF2 है या फिर LPF1 है?
वो डिपेंड करता है सिचुएशन के ऊपर. I'm just telling you can represent the band pass filter. It's a summation of two low pass filter, and the component of this band pass filter is two. One is the in phase and the other is the quadrature phase. Okay, I'm just telling this. I'm not relating the right side is your the quadrature or left side is your in phase. I'm just telling the band pass is a combination of two LPF. One is the in phase, another is the quadrature phase. Okay. Science Sudhir, are you getting this?
Yes, sir.
Okay, great. और मुझे नाम दिख नहीं रहे, 31 हो आप लोग, तो मैं पूछता हूँ किसी से, उसके बाद फिर आगे बढ़ेंगे. आदित्य, साई, कमल.
नो सर.
गुड. अनिल, प्रिया,
सर
कोई डाउट तो नहीं है बच्चे?
फाइन.
ओके, ठीक है. अच्छा, अरविंद.
नो सर.
नवरतन.
नो सर.
ओके. संदीप.
No, sir.
तरुण. तरुण, कोई डाउट तो नहीं है?
No, sir.
Okay, we will use this concept. Okay, remember, we will use the band pass is nothing but it's a summation of two low pass. One is the in phase and another is the quadrature phase. Okay, so we will use this concept to do the sampling of the band pass signal. Remember, why we are actually studying both low pass and band pass signal independent. Remember, the low pass sampling and the band pass sampling is totally different. Okay, so
So there's a lot
when
of
you
noise in your mic all of a sudden.
actually मेरा
Yes,
जो
sir.
विशाल मेरा घर है ना ये मार्केट के पास है
नहीं नहीं,
और
नॉइज एज इन वो स्टैटिक आ रहा है आपके माइक से, वो बैकग्राउंड नॉइज नहीं, स्टैटिक आ रहा है माइक से।
अब आ रहा है सॉरी सॉरी
यस सर।
इसका क्या सॉल्यूशन है कुछ बताएंगे विशाल मैं दोबारा देखता हूँ एक मिनट अभी आ रहा है
मेरा टोटल वॉइस
तो
सर
इसका
माइक डिस्कनेक्ट है, फिर से कनेक्ट करूं।
अच्छा अभी बताना मैंने फैन ऑफ किया शायद फैन की वजह से तो नहीं था
सर नहीं सर, वो पीछे का नॉइज नहीं है, वो कोई स्टैटिक है आपके माइक से, आपको ईयरफोन वगैरह किसी चीज का कनेक्शन में प्रॉब्लम प्रॉब्लम।
अभी भी स्टिल यू आर गेटिंग द नॉइज
यस सर।
अच्छा मैं रिकनेक्ट करता हूँ आप लोग सभी रहना
राजीव राजीव
भाई ढंग से माइक पकड़ ले।
राजीव भाई ढंग से पकड़ नहीं, क्या कर रहा है यार तुम?
भाई एक मेरे को कुछ समझ नहीं आ रहा मुझे क्या ही बोलूं।
अरे कौन सा माइक बोल रहा है सर?
अरविंद 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 क्या समझ में नहीं आ रहा राजीव
राजीव
दुनिया में सर वो मेरे माइक पे लेके क्या रहा था मैं कह रहा हूं भाई तेरी क्या बोल रही है बिना की थोड़ी जगह छोड़ दी
बस एक बोलो, राजीव मत बोल बेटा।
ठीक है भाई।
अच्छा अरविंद क्या समझ में नहीं आ रहा तो आप लोग अगर बताएंगे तो फिर मैं कैसे समझूंगा कि ये
अरे नहीं सर ऐसे नॉर्मल हमारा डिस्कशन अलग डिस्कशन था सर, राजीव से ऐसे बोला था मुझे।
तुम लोग बड़े डिस्कशन वाले होते जैसे मेरा टाइम होता हो तो डिस्कशन चालू हो जाता है जेएनयू खुल जाएगा तब डिस्कशन करना काफी ठीक है अभी अभी प्लीज अपने डाउट पूछ लेना क्योंकि ये बड़ा डिफिकल्ट टॉपिक है आगे वाला सैम्पलिंग ऑफ बैंड पास सिग्नल और उसको केयरफुली समझना और थोड़ा सा टिग्नोमेट्रिक रिलेशन की जरूरत पड़ेगी जो आप लोगों ने 12th में किया था 10+2 में सो उसकी थोड़ी जरूरत है आप नवरत्न आवाज अभी मेरा आवाज क्लियर है
सर माइक वो आवाज क्लियर है
सर आप बिना
कॉन्स्टेंट स्टैटिक है।
सर बिना माइक के वैसे एक महीना खत्म हो जाएगा हां जब 3 बार हां
अभी कैसा है ईशान एक बार हेल्प करोगे मेरी थोड़ा अभी आवाज कैसा है
सर नो चेंजेस।
अभी मैं दूसरा माइक चेंज करता हूँ एक सेकंड
सर ऑल ऑफ अ सडन बेटर हो गया आवाज।
अभी नॉइज आ रहा है स्टैटिक
अभी ठीक है।
नहीं सर अब बढ़िया।
चलो ठीक है तो माइक में कोई दिक्कत था दूसरा माइक सो आई एम जस्ट telling the difference between low pass and band pass filter. And all of you know now the band pass filter. The band pass filter is nothing but it's a summation of two low pass filters, and it has two components. One is the in-phase component, another is the quadrature phase component. Okay, so we will start, or in fact we will start our discussion by writing this band pass signal. So now see, you have the band pass signal is so this is the bandwidth. Okay, similarly you can have here okay. Anybody please? Okay.
Sir, please share the screen.
So are you getting my voice?
Yes, sir.
Okay. Yes, sir. Up to this it is clear. So this is the representation of the band pass signal.
You haven't presented
सर
anything.
स्क्रीन नहीं प्रेजेंट कर रहे हैं
Oh,
Yes, sir, कुछ भी नहीं कर रहा है।
sorry. I'm so sorry. I'm so sorry. Actually, I forget because yeah. So this is the representation of the band pass signal. Now screen is getting.
यस सर
Okay. So see. So now you can represent this band pass signal. This is GT in time domain, and in fact this is the Fourier transform signal of this. Okay, so GT you can simply say sum of two low pass filter. Okay, so one is in phase and other is quadrature. Okay, so now see, so we say in phase component, in fact, or we can write in general. So you will find in actually this is the same. I don't know whether you already did or not, but this is the main part of the signal system when you break the signal, the band pass signal into two components. One is the in phase and other is the quadrature phase component. So I'm just writing that, and I'm not going into the detail how this equation comes for the band pass signal. So as I already mentioned, so the theoretically the band pass signal is the summation of two components of the low pass filter. One is the in phase and another is the quadrature phase component. But I am not going in the in the derivation of that equation. So you just remember this derivation, this equation. This equation has two components. One is the in phase component, other is the quadrature component. So now the band pass signal. So you can write this band pass signal is here zt, which is in time domain, simply gct. Okay, and the cos 2 pi fct minus gst sine 2 pi fct. Okay, see, dt is the band pass signal and it is the summation of, or in fact it has two components. One is the quadrature phase component and other is the in phase component. Okay, and both component, the quadrature or in phase, or we can say in ये गड़बड़ हो जाता है. In phase and quadrature both are okay. In phase and quadrature are with respect to carrier frequency. So if you see here in this equation, just change the size of that. So this is here again the FC, here is the FC. So in both the component, the GCT and GST, so the carrier frequency is same or with respect to the carrier frequency. So here GCT is nothing but it's a in phase component. Or and this GST is your quadrature phase component. Remember, C here means for the simplicity because this is the cosine function here, and S for the sine. So this is just simply to write here. In fact, this is your quadrature component, this is your in phase component. So we will use this equation. Remember, so if you see, okay, if you see here, this is one low pass filter and this is another low pass filter. Okay, you already discussed this portion, the reconstruction of this low pass filter, and now we will do the reconstruction of this band pass signal. And this band pass signal is made of two low pass component, and one low pass component is in the phase, in phase, and other is in the quadrature phase. Okay, so this is one thing, and all of you remember this thing because we have to reconstruct. I'm getting phone. I don't know who is he. Hello. Sorry, I'm so sorry. Okay, now come to another assumption. So to reconstruct here, we assume, so the assumption is here, we assume the highest frequency. We assume that highest frequency. Okay, highest frequency component of this GT or this band pass signal is FCW. Okay, of this is, so remember this. So this is your FC. This point is FC plus W, and this is your FC minus W. So this is the highest frequency component. So this is, you can say it's assumption, or you can say it's the band pass response has the carrier FC and the bandwidth is twice of F. So if you see, if you find the bandwidth, so bandwidth is here is twice of W. Okay. So the bandwidth of this signal and the signal is BPF, band pass signal. Okay. So the bandwidth is twice of W. Okay, or we say it's twice of FM. Okay, so this is the assumption, and we this is the simply the bandwidth, and we assume here. So this bandwidth or this highest frequency, the highest frequency is integer multiple of the bandwidth 2. Okay, so this highest frequency component is FC. It's nothing but it's a integer multiple of bandwidth. So this is your bandwidth. And why we do this, I will explain you next when we go for the next, actually next sum equation. So here the assumption is simply, this is the assumption. So the highest frequency component, this is nothing but it is a integer multiple of the bandwidth. The bandwidth is your twice of W. In case of low pass filter, the bandwidth is W, but in case of band pass, it is twice of W. And this is your integer. So integer multiple of this bandwidth. So from this equation, if you solve, so this is FC is equal to 2K minus 1 W. Okay. Okay. And for the sample signal, what we do, the sampling instant. Okay. The sampling instant, what we write, this T is equal to NTS. We just substitute this value as in case of low pass filter. We already done this. We just substitute the T equal to NTS when we did the sampling. Okay, so this is the simple way. And here again, N is another integer and its value is 0 plus minus 1 plus minus 2, and that will go on. So you can see the T will split into the NTS, and T is the sampling rate or sampling instant. Okay, so this is one thing. Now if you see, when we do this, so what will you have? And the equation, if you substitute T equal to NTS in the equation 1, which we have already, this one in the equation, this equation, this is okay. So this is equation 1. So we just substitute this T NTS. So what will you have? So the equation is now the T is equal to NTS, and here N is equal to 0, not 0. It's plus minus 1 Okay, that's it. Okay. Plus minus 1 plus minus 2, and that will go on this. So now the equation 1 becomes, so this gt is equal to, so this gt, this is not t, but now you just substitute this value. So g and ts is equal to now, so this is your in phase component and this is your ts, and this becomes cos 2 and pi fc ts. Okay, this is your in phase component, and similar you have the quadrature component. So this is again this, and sine 2 pi and fc ts. So we just substitute this value in the equation 1. So now this is your equation 2. Okay, and we know for the sampling rate, this is ts, 1 upon ts, this is your sampling rate. The sampling rate is equal to twice of bandwidth. So here the bandwidth is 2w, so that will give you 4w. Okay, and from this equation, if you see, the ts is equal is 4w. So see, this is. So what will we do next? We substitute this ts here, 1 upon 4w. Okay, anybody किसी को कोई क्वेश्चन हो, कोई डाउट हो तो प्लीज आस्क. Anybody please.
सर ये TS is equal to 2 times of bandwidth हमने नाइक्रोस्टेट के लिए किया है क्या?
हाँ. This is Nyquist criteria for the sampling. So all of you know. So the sampling rate is always greater than of this twice of bandwidth. Okay.
So वैसे greater than ही लिखना चाहिए ना हमें, मतलब practically equal to की जगह.
Yeah, for the sampling, जैसे मैंने last class में explain किया था, but the theoretically you can take the equal. But when we discuss the practically, that should be slightly higher than that, or greater than that, twice of that. But here for the simplicity, we just taking equal to the twice of bandwidth. Okay.
Okay, sir.
Okay. Any Ishan?
No, sir, none.
Okay. Keram, are you there? Please पूछ लेना. Actually, this is not a whiteboard, a real whiteboard. So मैं कोशिश कर रहा हूँ. I'm just trying to write. अगर ठीक तरह से नहीं लिखा जाता, नहीं समझ में आता, तो you just please ask. Unmute yourself and ask. Okay. So if you substitute that value, the equation becomes now. So we just substitute the Ts is equal to 1 upon 4w. So this is now, this equation is this. Very simple expression. So this is your n upon 4w. This is 2 pi. Very simple expression. We just doing systematically step by step. So you definitely you will understand when you do yourself, when you read yourself. Okay, this is gs n upon 4w, and this is sine 2 pi fc n 4w. Okay, so now you have this equation. Okay, remember why we are doing this. Our objective is to reconstruct when you have the band pass signal, and band pass signal means the signal which has some bandwidth, some narrow bandwidth. Okay, while in case of low pass filter we say it's a cutoff frequency. So that cutoff frequency is represented like a bandwidth, but here we have a band of frequency, and when we do the sampling of band of frequency, you have the sampled version of the signal, but at the receiver, to recover the band pass signal, it's not easy as compared to the low pass signal. So if you see, the mathematics is also difficult, but ultimately we can get by finding the quadrature in phase component. Actually, if you see, this equation uh, uh, has two components. These two are unknown. We know the carrier frequency, we know the n and the sample, we know the bandwidth, so we can find this cosine easily and the sine also, but we don't know this, the in phase component and the quadrature component. So we know the equation of the band pass signal, and the band pass signal is simply, you can write it the in phase and the quadrature phase component. But how we can find these two components, the quadrature and this, the sorry, this in phase and this quadrature component. So whatever the mathematics we are doing here to just to find these two components. So if you understand how we can find these two components, so you can just simply write the reconstruction formula. You just simply, you can easily drive this the reconstruction formula. So our main objective is here to reconstruct the original signal from the band pass signal, and band pass signal is split into two components, in phase and quadrature phase. When you split in the in phase and quadrature component, you have these two terms, the in phase and the quadrature component. So we have to find these two terms, and whatever the mathematics we are doing here, just to find these two terms, GC and GS. Okay, ये सभी को समझ में आया? So the जितना भी mathematics we are